In the last video, we covered continuity at a point and we did some practice questions for it. In this video, we'll cover continuity of common functions. And in the next video, we will cover removable discontinuity. So let's jump on to continuity of common functions and try solving some questions. So anytime we have a numerical value as an answer, it would be continuous. And anytime we have a zero in the denominator or any other way it is not defined, then it is not continuous. So our first question is cot of x. I'm imagining that everyone has memorized the formula sheet by now. So we would know that cot of x is simply 1 over tan of x, and tan of x is sin x divided by cos x. So this would become cos x divided by sin x. Now we know the tip is to simply try substituting for 0. So cos of 0 divided by sin of 0. Cos of 0, we know that it is 1 and sin of 0 is 0. From the formula sheet, if you guys don't know, then you should remember or memorize it. So we can see that we have a 0 in the denominator, and whenever 0 is in the denominator, then it is not continuous. So cot of x is not continuous for all real numbers. Next question, 1 over x square. So if I simply substitute for 0, it would be 1 over 0 square, which is simply 1 over 0. And as 0 is in the denominator, this is not continuous for all real numbers. It might be continuous for some points, for some portions, but not for all real numbers. Question 3, when we have a power. So if we are substitute for 0, anything power 0 is simply 1. So we have got a numerical value and this is continuous for all real numbers. For the next 3 questions, you have to remember the properties of each. For our first question, ln questions, you have to remember that ln graphs are only defined for positive numbers. It is not even defined for 0. So if I plug in any value inside this x, so the entire expression becomes 0 or negative, it would not be defined. So I can plug in maybe 3. ln 3 minus 3 is equal to ln of 0, which is not defined, or any negative value. ln 1 minus 3, which is ln negative 2, or maybe ln negative 5 minus negative 3, which is ln negative 8. So these are not defined for these points, and hence it is not continuous for all real numbers, because negative numbers are also real numbers. So in order to prove that it is not defined for all real numbers, you have to plug in any value inside x, so the whole expression would become negative. For questions where e is in the power of x, you only have to remember that it is continuous for all real numbers. You can plug in any value and just say that it is continuous. So maybe I can say e 3 minus 3 is equal to e power 0, and e power 0, anything power 0 we know is 1. So I'll say it is continuous. And lastly, where x is inside an under root sign, for these, they are not defined for all negative numbers. You know that if the under root of a negative value does not exist, so I can simply say under root of negative 5, and this does not exist, so it is not continuous for all real numbers. A different variation of this question can be where x is over here. For any of such question, we know that we can also write it as 1 over x, and we know whenever 0 is in the denominator, it is not defined, so it is not continuous for all real numbers, and you can simply plug in 0 and identify.